Hey everyone, welcome back to Ms. Contreras Math. I am Ms. Contreras, and today we are going to be talking about adding and subtracting fractions with unlike denominators. So before we get into the addition and the steps to solve this problem, we need to really discuss the why behind all of the steps that we're about to do. Now, you can see on the screen that I have two fractions, 1/2 and 1/8. Now, a lot of my students would rather just take those two numerators and put them together, but the problem comes whenever you have those two denominators and they want to add those together as well. 2 plus 8 is 10. But the problem with that is you're not taking into consideration the value of those two pieces. So I'm going to show them to you now. So that 1/2 is me taking that circle and splitting it into two parts. And if I shade in one of those parts, that is the value of 1/2. I've shaded in half of that circle, and that's the value of that piece. And then on the other side of that, I have 1/8. And 1/8 is me taking that circle and splitting it into 8 parts. Now, ideally, these would be equal sized parts, but I'm not a perfect person, so these are not perfect size pieces. But you can immediately see the drastic difference of what the value of half of a circle is versus the value of 1/8 of a circle. 1/8 of that circle is a very tiny piece of it. And so if I were just to add those two values together and get 2/10, my pieces would be even smaller than they are right now, because 10 as the denominator is talking about taking that circle and splitting it into 10 parts. That's like taking a pie and sharing that one pie with 10 people. Those pieces are not going to be very big. So when I'm taking these two values and I want to add them together, there is a strategy that I use called remembering your Skittles, because the steps within them with adding and subtracting fractions with uncommon denominators, they are not difficult, but it is difficult sometimes to remember what steps you're supposed to do. So what I feel like is you've done all this work, so you've earned a Skittle. And most adding and subtracting fractions problems are going to be 3 Skittle problems. So let's talk about what those Skittles are. So all of them will be 3 Skittle problems, but there will sometimes be a 4th Skittle that needs to be done. So what are the Skittles? Well, the first one is we need to be adding the same values together. We need to be adding pieces together that are the same size, and we don't have that in our current setup. So our first step is going to be finding what's called the LCM. LCM stands for least common multiple. Least common multiple is taking those two denominators and skip counting until we find the smallest value that both sides have in common with each other. The second step after you found that is to apply it to your fractions that you started with and get what's called equivalent fractions. Equivalent fractions mean that the pieces are equal to what they started with. I'm not changing how much was shaded in on my circles. I am just changing what they look like, but the value stays the same. Now, the third Skittle is us actually doing the operation, adding. Now, the final Skittle that we have is not always going to be there. The final Skittle is only if the value we get for the answer needs to be reduced. So we say reduce if necessary, RIN. Okay, without further ado, let's get into our Skittles. So our first Skittle, like I said, is the LCM, finding the least common multiple that our two denominators have in common. So that means the first thing I'm going to do is skip count by 2's. So we've got 2, 4, 6, 8, 10. Now on the other denominator is an 8, so I'm going to skip count by 8's until I see one that I have in common on the other side. 8, 16, 24, you get the idea. Now, I stopped so soon because I already had two values that are the same on both sides. The smallest value that I have in common on both sides is 8, which means that my LCM is 8. 8 becomes our new denominator for our equivalent fractions. So we've done our first Skittle. We've completed the LCM. Now we know what our pieces should be divided into so that we can finally add them together. But before we can do that, we need to find the equivalent fraction. Now, since 1/8 already has 8 as the denominator, I don't need to change it. That stays 1/8 because it's not going to need to be changed because 8's already there. So we will change 1/2 to where it has an 8 as the denominator. And we get there by what we multiplied. This was 2 times 1 times 2 times 3 times 4. So 2 times 4 was 8, and I have to multiply the numerator by that same value, 1 times 4. 1 times 4 is 4, so 1/2 is equivalent to 4/8. That's my equivalent fraction. 4/8. So now that I have two denominators that are the same, I can actually do the operation. I can do the operation of 4/8 plus 1/8. 4/8 plus 1/8, the denominators do not change because I'm talking about pieces that are the same size, and now I'm just adding them together. The denominator is still 8ths, but I add the numerators together, and it's 5/8. So I've actually done the operation. I've earned my third Skittle, and this cannot be reduced. 5/8 is its simplest form, so I had nothing to reduce. My sum is 5/8. So we're going to review the Skittles again, and we're going to talk about how to solve these problems even when we're dealing with much bigger denominators. So once we get that on here and we get into the habit of remembering those Skittles, you will have earned them. All right, so now we are going to talk about what happens when you have to change both fractions because neither of them are going to have the same denominator that they had originally. Now, we saw from before that the reason we have to do this is because those pieces are two completely different sizes. They're two completely different values. It'd be like adding cats plus feathers. It doesn't make sense. So we have to make sure that we remember our Skittles. Our Skittles are not difficult steps, but there are quite a few of them, which is why you earn them along the way. So our first step is finding the least common multiple of our denominators, the down numbers. 9 and 6, we are going to be finding the multiples or skip counting by 9s and 6s until we find one that we've got in common. After we do that, we will find the equivalent fractions with our new denominator. Then we will have to actually do the operation, which is adding. And then the last step is going to be reduce if necessary. It may not be necessary, and then again, it might be. So, before I get too far into that, let's talk about a strategy that you might have seen before that is not recommended. And it only works half of the time. I'm not even going to put it on here because we're just going to talk about it and why we're going to avoid it. Now, I teach 5th grade, which means that I am preparing my kiddos for middle school. And I've heard from middle school teachers to kill the butterfly. We are not going to be doing the butterfly method. And here's why. For one, it doesn't teach you the why behind it. You are only doing the skill, and that's only half of the explanation. We need so much more to the story. And for 2, it only works for adding. It only works for adding because sometimes when you have 2 numbers together that you're subtracting, you've seen it with whole numbers that sometimes we have to regroup. You can't regroup with the butterfly. And when you're doing that butterfly method, you're actually causing yourself to do more work. So if you were coming here looking for the steps to solving the butterfly method, then I'm sorry, I'm not going to be teaching that to you. The steps that I'm showing you here are going to work for you and give you the right answer every single time, as well as teaching you what you're actually doing whenever you're solving these problems. So, rant aside, let's get into our Skittles. So, our first step we said is finding the LCM. We are skip counting by 9s and skip counting by 6s. So, skip counting by 9s, we have 9, 18, 27, 36. Okay, now we're going to move over to our 6s. We've got 6, 12, 18, 24. So, do we see what we've got in common here? The smallest number that we have in common between our 2 multiple sets is 18. So 18 is our LCM. 18 becomes our new denominator. So that is a Skittle we can check off the list. Then we move over to our equivalent fractions. We take 4/9 and we are going to set it up just like this. Remember, equivalent means equal value. So that's why you see I've got 4/9 is equal to a number of 18ths. We're going to do the same thing with 5/6. 5/6 is equal to how many 18ths? So this is where your multiplication comes in. You can number these over here if you need to, because we already did the multiplication, so you might as well use that information. What did you multiply 9 by in order to get 18? 2. So what's happening here is we're multiplying it actually by 1. And when you multiply anything by 1, you get that same number on the other side. But when we're talking about fractions, it's still going to be equal to what it is on the other side. This is what 1 whole looks like as a fraction. So we're multiplying it by 1 whole. 9 times 2 is 18. 4 times 2 is 8. So 4/9 is equivalent to 8/18. We're going to do the same thing for 5/6. 6 times 3 is 18. 1 whole as a fraction would be 3/3. So 6 times 3 is 18. 5 times 3 is 15. So now we're looking at 5/6 is equivalent to 15/18. We have found our equivalent fractions, so now we can actually get to the addition, which is the whole purpose of this problem. So let's see, changing my colors here. 8/18 plus 15/18 is going to keep its denominator, and now we're just adding 8 plus 15. Now 8 plus 15 is going to give us 23. So we've done the operation, we have earned our third Skittle, but now you can see that the sum I got is improper. So we are going to have that extra step of reducing. We're about to earn a fourth Skittle. So fractions are just division problems. You take that numerator and divide it by your denominator. So the 23 will go in the house. It is our dividend. And 18 is our divisor. 18 is our divisor. Now, I cannot take 18 away from 2, but I can take 18 out of 23. I can take one group of 18 from 23. And 1 times 18 is 18. Now we subtract 23 minus 18 is 5. So what I'm doing here, the whole reason I'm doing the division is because 23 has an equivalent fraction too, and it's about to be represented as a mixed number, a whole number with a fraction. This 5 that we have left over is actually a fraction. It is our new numerator, 1 whole and 5 out of what we divided by 18. 1 and 5/18. So we have reduced if necessary. We have earned a fourth Skittle. So these are the steps to solve it. Please watch this video however many times you need to for this concept to sink in. This will get you the correct answer every single time, no matter if you are adding or subtracting different fractions with uncommon denominators. And here shortly I will show you what happens when you need to regroup on a subtraction with fractions with uncommon denominators problem. Okay, so now we are going to take that same information, that same strategy set of remembering your Skittles, and apply it to this subtraction problem. Now, this is a couple steps ahead of what I would normally do in the classroom. We wouldn't go straight into subtracting mixed numbers, but we're going to apply that same skill set to this, and yeah. So let's just get into it. We are still dealing with two different denominators, which means that we cannot subtract them the way this looks right now. We can't subtract them because those pieces are not the same size, and we're not talking about the same values here. So one thing I do want to address real quick is that I know a lot of students have difficulty realizing that 2 4/9 is one piece together. It is one value together. A lot of people like to completely separate those and just say it's 2. No, you still have that 4/9 attached to it. That still needs to be included in the problem, because my kiddos like to say 2 minus 1 is 1, so our answer should be 1. You're completely ignoring half of the problem when you do that. So just like any subtraction with whole numbers or decimals problem, you have to line those numbers up before you subtract them. And we are not going to be solving them horizontally. So I am going to set my problem up 2 4/9 minus 1 5/6. So I've got my fractions lined up, I've got my whole numbers lined up. And just like whenever you're solving those other subtraction problems, you have to start with the smaller values and work your way over to the larger values. So we're going to start with the fractions and subtract those first before I can move over to those whole numbers. Now, these are the same fractions from the last problem we solved when we were adding them. So we already know our LCM is 18, and we know what our equivalent fractions are. So 4/9 is equivalent to a certain number of 18ths, and so is 5/6. So 9 times 2 is 18, 4 times 2 is 8. So we're actually going to change that from 2 4/9 to 2 8/18. We're going to change that from 1 5/6 to 1 15/18. So I'm going to erase this part because we're not looking at those numbers anymore. And we are going to take these and move them over. Okay. So now, just like I said before, we are going to start by subtracting the fractions before we can move over to the whole numbers. Now, you may have just noticed something. We cannot take 15 away from 8. So, just like what would happen in a normal whole number subtraction, the same thing is going to happen here. We are going to regroup from that 2. We're not borrowing from it because we're actually not borrowing anything. It's still going to be 2 8/18. It's just going to look a little different. So here is what we are doing. I am going, if I can get my brushes back, I am going to borrow 1 whole from that 2, and I'm going to give that 1 whole to my fraction. Now, earlier in this video, we talked about what 1 whole looks like as a fraction. It is when you have the same numerator and denominator. And how do you add 2 fractions together? Well, the denominators have to be the same. So our denominator is 18. And if I want this to be 1 whole, then I need 18 on the top as well. That is 1 whole. And now we're going to add them. Now, 8 plus 18 is going to give me 26. And our denominator will not change. So now, can I take 15 from 26? And the answer is yes, I can. So 6 minus 5 is 1. And 2 minus 1 is 1. So 26 minus 15 is 11. And then 18 is going to be the same because our denominators will not change. And then 1 minus 1 is 0. So our difference here is 11/18. So I know that this is a hard concept to wrap ourselves around. Anytime we hear the word fractions, even as adults, we shudder a little bit. We get chills. But the steps that I use are not difficult themselves, but they are involved, and there are quite a few of them, which is why you need to get yourself a bag of Skittles. And when you solve these out, remember them. Remember your Skittles, and you've earned them along the way. I hope this video helps. Please check back for more soon. Thank you so much.